estimation steps here. A lot of you guys already are pretty good at rounding to easy numbers, doing the operation, and now we're going to look at if we have overestimates and underestimates, and then take that to a harder problem today. So here's a basic, simple example where you guys just told me, like Scout was saying, he could take this 6, the 0.673 or 673 thousandths, and just change it to 1. Once he does that, he's got an overestimate because he made this number bigger. So his estimate is 14.1. It's an estimate, it's an overestimate. What Ellie did was she said, well, I could go down to 0.5. So that's like half of 14.1, right? So Ellie, what's about your answer?
It would be 7.02.
Yeah, so we're going to say about 7. But you're right. It's about 7. So our actual answer should be between 7 and 14.1. So there's an underestimate idea and an overestimate idea. Questions? Yeah, Aiden.
What about 14.1? Can you underestimate that to this 14?
You could. So sometimes, so let's get rid of some of this stuff. So absolutely, you could do both, but sometimes.
But you'd want to do like the one that'd be easier.
Sometimes you just want to make sure if you did change them both, which we do a lot, then you probably want to change them in the same direction. Because if you change one down and one up, you won't really be able to tell if it's an overestimate or an underestimate. So a third method, which is probably what most of us might do, is think of this as half of 14, which is really what I did when Ellie said half of 14.1. So I made this a whole number, and I just made that a benchmark fraction. And so because I rounded both of them down, I have an underestimate. What you don't want to do is round one down and one up. Not if you have to tell if it's an overestimate or an underestimate. Okay, sometimes you can round one down and one up, but then then the question would be different. So the goal today is, if you're trying to decide if you overestimate or if you underestimate, a good habit is to change one number or change them both in the same direction. Does that make sense? Questions, you guys? Okay, Ellie.
6 and 3 to 70.
Angel, this is for you. You go now. Could you round 0.673? Well, you could, but it's not quick. I mean, estimation's for quickness. Okay, so it wouldn't be something you would do here. Remember, when we estimate, we want to make things kind of quick. So here's where you're going to use this a little bit more specifically. You have some problems in your homework that are different. Instead of just asking you to estimate, can you see this problem back there? Problem 10 in your homework, this is an example. It doesn't really just say estimate, it expects you to do more. I'm going to just pause this to write it down. So it wants you to figure this problem out by answering only if it's more than 56 or less than 56. So I want you to give me your opinion and then tell me why. Not just an answer, but tell me why. So Sean.
It's more than 56
Oh. So he says more.
because
Can you do an estimate? Or tell me why?
well, because you're not just you're adding or you're multiplying 8 and a little bit to 7 and a little bit.
Okay. So the way I would put that in writing, just so everybody can kind of listen to what you're saying, his estimate, if you heard what he said, was 8 and a little bit and 7 and a little bit. His estimate was really 8 times 7. So he did round both numbers, but he rounded them both down. So he now knows he has an underestimate because he went down. So this is an underestimate. And so when you make an underestimate, that means the answer you estimated is a little too small. So the real answer has to be more. See that? Jake.
when you do it, and he's like, oh, well, because I have this little mark, but then you, like, way over estimate, like, added, let's say, 3 or maybe 4.
Well, you don't want to way overestimate usually. Estimating is to help us get close. So usually you have some reasons for estimating. Overestimating is a good thing to do when you go shopping.
Then you know exactly.
Because then you know exactly, you know that if you have enough money or not. Sometimes underestimating is a good thing to do. Like if you, I'm trying to think, underestimating might be good when you are seeing if, I have to think of a good example. Like if you're seeing how many people you can invite to a party. You might want to, like, or if you have enough stuff for all of your friends, you might want to underestimate the amount of people you could bring so nobody's left out. So, but if you're trying to make sure you have enough party supplies, you want to overestimate the supplies. So there's different times you would overestimate or underestimate. So, does that help?
Yeah.
Okay. When you look at number 12 on your worksheet, it's this problem, 96 hundredths times 12.8. So Kate, what are you going to do and why?
Oh, I think it's less.
You think the answer is less than 12.8?
Because if you rounded it up, it would actually be exactly 12.8.
Okay.
So, it's less than 1, so it's less than 3.
So I hear what you're saying. I think you're rounding this to 1. So your estimate is 1 times 12.8, which is 12.8. So those, if you look at our directions, those are easy numbers. He did the operation, and now he already knows he made one. He rounded 96 up, so his answer is too big. So the actual answer has to be smaller than 12.8. So this is less. Sounds good.
So if it's exactly the number, you just go less?
Well,
It's not more.
okay, the reason I went more is because I changed 96 to a bigger number. And so my whole answer, my whole estimate's already going to be bigger than the real thing. Do you get that? Try the next one, Aiden. And then we'll do questions. So on this one, you see that? You're going to pick an easy number. So the first thing that comes to mind when you see that makes it easier would be what?
Rounding down to 5. Or up. Oh, no, down.
Okay, what if I gave you choices? I think it might affect your answer. What if I said, is this more? I should have given you the choices. Than 800? Or is it less than 800? So when you have choices, before you start the problem, like the multiple choice, you kind of look and say, how can I make this problem estimate to help me pick one of those answers?
When you do 4,
you would do 4. Yeah, you would do 4 times, you could do 4 times 209, and you could even do 4 times 200. As long as you round them both down, so which would you like to do, 209 or 200? So that's okay because he rounded them both down. So 4 times 200 is 800. But this estimate here is an underestimate. It's smaller than the real thing. So the real thing has to be more.
So if you underestimate, it's going to be smaller than the real?
Than the actual.
If you...
You get that? Okay. Right. Okay, it's not a matter of can't. It's a good question. You don't have to write this in your notebook, you guys. If I just said estimate, and I said 4.1 times 2.0, 209, okay? And I didn't ask you anything else. I didn't ask you if it was more or less than a number. It's more like the first thing I did was just give me an estimate, like we did in the beginning. If I just said give me an estimate, then you could, Mike, you could say, well, that's about 4 times 210, that's my estimate, I'm pretty good at multiplication. My estimate's 840. That's an estimate. Nothing wrong with that. But if I want you to tell me, so what you did here was you rounded the 4 down and you rounded the 209 up. It's still a good estimate, but you can't really tell as well now if you round 1 down and 1 up, if you made an underestimate or if you made an overestimate. So it depends on the question. If I'm asking you to tell me if it's an underestimate or an overestimate, you kind of want to run them both in the same direction or round only one number. Because once you round 1 up and 1 down, it's hard to tell. So it's not wrong, it's a different estimation technique. Okay? Ellie? In a minute. Any other questions?
If it's always a decimal, like below, like 0.96 times 12.8.
Uh-huh.
Would it, so is that like, it's not like, decimal 0.96, then you'd always go down, right? Because it becomes, because you have to move the decimal along the same. Like it's not moving up.
I don't know what it is. What are you talking
Well,
about?
like 0.96, if you multiply it times 12.8, it goes down, not up.
Okay, that's a good thing to point out. Whenever you take a number less than 1, like this is less than 1, whatever you're multiplying it by is going to get smaller. That's another way to think of it, which is also really important to think about. Okay, I'm going to stop that there.